So let's look at a compound angle problem. We're given this little triangle here, and we can see that we've got an angle P, which is the small angle, and we've got the angle Q, which is the large angle, and we've got this distance is 2, this distance is 1, and this distance is 4. And we're told to find the angle cos of Q minus P. Well, there's Q there, and there's P. So when you do Q minus P, you get this angle here. So I'll just draw that. So that angle there is the angle Q minus P. So we're looking for the cosine of this little angle in here. Now, we can do that by using the compound angle formula. So if we were to check up and see the compound angle formulas that we created, we can rewrite this cos of Q minus P. Well, that's going to equal our cos of Q, cos of P, plus the sine of Q times the sine of P. Now don't worry if you don't remember that formula, because if you were, say, sitting an exam or you were going to be using any of these formulas, you would have access to them, so you wouldn't be expected to memorise these sorts of things. And as I said, in mathematics you don't want to spend your time memorising lots of formulas. Some of the ones that you're going to use more often, you would just have access to them in tables. So now we need to find out what each of these things are. But we can work those out from the actual diagram here and use the simple Pythagoras. So in Pythagoras, this is a right angle here. So we're going to have this length here is going to be this length squared plus that length squared, and it'll be the square root. So that will be 3 squared plus 4 squared, which will be 25. The square root of 25 will give you a value of 5. Or it's usually you would know a few of these common Pythagorean numbers. So for example, this is going to be a 3, a 4 and a 5 triangle. So that's the most common known Pythagorean units. So 3 squared plus 4 squared is equal to 5 squared. So we've got this length here, but then we can do the same if we were to work out this length here. So we could have 4 squared plus 1 squared, which is 17, and we take the root of it, so that length there would be the root of 17. So now we've got all the information we need in order to work this out, and we just have to put these values in. So we're going to have the cos of Q. Well, this is the Q angle here, so it's the big triangle, and we're finding the cosine, which is going to be the opposite, so it's going to be the adjacent over the hypotenuse. So that's going to be the 4 upon 5. And then we can look at the cos of P. Well, P is a small angle, so the cos of P is going to be 4 upon root 17. And then we're going to add on the sine of Q. Well, Q is a big angle, but the sine of the big angle is going to be the opposite over the hypotenuse, which is going to be 3 upon 5. And the sine P is going to be the sine of the small angle. Again, it's the opposite over the hypotenuse, so it's going to be times 1 upon the root of 17. So we can rewrite this here, and we can say that's equivalent to 4 times 4 is 16 upon our 5 root 17. And the second one here is going to be 3 upon 5 root 17. So therefore we can add these two together, and we're simply going to be left with 19 upon 5 root 17. So this here is going to give us the cosine of this little angle Q minus P. So that's a typical sort of exam question that you would tend to get, and we'll go through another one of these whenever we look at the quiz section. So thank you for listening. I'll get you in the next video. Goodbye.